Hi, today we are going to talk about the blockchain elements and how this blockchain technology is used for the cryptocurrencies like Bitcoin. We'll see some of them. To follow this, the optional reading textbooks are one is Mastering Blockchain, that is chapter 1, which describes the blockchain versions, and the second one is the Solidity Programming Essential book, where it gives the introduction to blockchain regarding the Ethereum and the smart contracts. So the agenda in the introduction to blockchain, so there are various definitions are there for this blockchain. So it depends on how you look at it. So if you look at it from a business perspective, it can be defined in that context. If you look at it from a technical perspective, one can define it in view of that. But we are talking about the technical perspective only, not in terms of the business perspective. So the blockchain, at its core, is a peer-to-peer distributed ledger that is cryptographically secure uh, and append only, immutable, that is extremely hard to change, and updatable only via consensus or agreement among peers. So that is the one definition regarding that. And the second one is the blockchain can be thought of as a layer of distributed peer to peer network running on top of the internet, as can be seen in this diagram. It is analogous to SMTP, HTTP, or the FTP running on top of the TCP/IP suite. So this is the way of defining that it is just a peer-to-peer network. So what is actually the blockchain then? So the blockchain can defined as the is essentially a decentralized, distributed, or a ledger as follows: that decentralization and what you call the distributed database, and uh, so this is a ledger as follows: that decentralization, distributed database, or ledger. So what is this decentralization? So decentralization means, in simple term, it means that the application or service continues to be available and usable even if a server or a group of servers on a network crashes or is not available. So the service or application is deployed on a network in a way that no server has absolute control over data and execution. Rather, each server has a current copy of data and execution logic. So, what about the distributed one? So, the distributed concept derives that this means that any server or node on a network is connected to every other node on the network, rather than having one to one or one to many connectivity between servers, and servers have many to many connections with other servers. So that is distributed one. So suppose if you have three nodes in the network, every node is connected to every other node. So that is distributed one. And next one is the database. So in database, it defines that this refers to the location for storing durable data that can be accessed at any point in time. A database allows storage and the retrieval of data as functionality and also provides management functionalities to manage data efficiently, such as export data, import data, backup data, and restorations. So these are the various functionalities, and the next one is ledger. It is defined. Blockchain is defined as a ledger. Also. This means an account term. Ledger is an account term. So think of it as specialized storage and retrieval of data. Think of ledgers that are available to banks. For example, when a transaction is executed with a bank, say Tom deposit $100, suppose, in his account, then the bank enters this information in a ledger as a credit, and the bank at some point in the future, Tom withdraws, suppose withdraws, suppose $25, suppose. Okay. So then the bank does not modify the existing entry of this, right? And simply store data from 100 to 75. Instead, it adds another entry in the same ledger as a debit of $25 in that ledger form. So that is deposited amount and the withdrawal amount. So it means a ledger is a specialized database that does not allow modifications of existing data. It allows you to create and append a new transaction to modify the current balance in the ledger. So the blockchain is a database that has the same characteristics of a ledger. It allows newer transaction to be stored in an append only pattern without any scope to modify past transactions. So it is important here to understand that existing data can be modified by using a new transaction, but past transaction cannot be modified. A balance of $100 can be modified at any time by executing a new debit or credit transactions from the Tom's account. Okay, but but the previous transactions cannot be modified. So that is the meaning of the ledger. So if you think about this, the blockchain means a chain of your blocks. So blockchain means having multiple blocks like block 1, your block 2, block 3, and so up to suppose block 4, block 5, and block 6. So having multiple blocks chained together by using this chain system, with each block storing transactions in a way where it is not possible to change these transactions. So, because of being decentralized and distributed, blockchain solutions are stable, robust, durable, and highly available. So, there is no single point of failure in this case. No single node or server is the owner of the data and solution, and everyone participates as a stakeholder in this network. So, not being able to change and modify past transactions makes blockchain solution highly trustworthy, transparent, and incorruptible. So that is the basic definition of your blockchain. So, but why this blockchain technology is required? Why? So, for that, the main objective of the blockchain technology is to accept transactions from accounts, update their states, and maintain this state as current till another transaction updates it again. The whole process of accepting, executing, and writing transactions can be divided into two phases. So there is a decoupling between when a transaction is accepted by the blockchain and when the transaction is executed and returned to the ledger. So this decoupling is quite important for decentralization and distributed architecture to work as expected. So blockchain helps primarily in the three different ways. One is the trust. So blockchain helps in creating applications that are decentralized and collectively owned by multiple people. So nobody within this group has the power to change or delete previous transactions. So even if someone tries to do so, it will not be accepted by other stakeholders. So that is the trust is the one way. And the second one is the autonomy. Means what? There is no single owner for blockchain based applications. So no one controls the blockchain, but everyone participates in its activities. So this helps in creating solutions that cannot be manipulated or induce corruption. And third most way which helps this blockchain is intermediaries. Intermediaries. Right? So in this intermediaries, the blockchain based applications can help remove the intermediaries from existing processes. Generally, there is a central body such as a vehicle registration or license issuing and so on. So that act as a registrar for registering vehicles as well as assuming driver licenses. Issuing the driver's licenses. So without blockchain based systems, there is no central body, and if a license is issued or vehicle is registered after a blockchain mining process, that will remain a fact for an epoch time period without the need of any central authority watching for it. So blockchain is heavily dependent on cryptography technologies as we discussed in the previous sections. So let us see what are the various technical definitions are there for this blockchain technology. You can see the first one is the blockchain is a decentralized consensus mechanism. That means in a blockchain, all peers eventually come to an agreement regarding the state of a transaction. And second way of defining the blockchain is a distributed shared ledger, which we just discussed. So blockchain can be considered as a shared ledger of your transactions. So the transactions are ordered and grouped into blocks. A third way of defining is blockchain is a data structure. So it is basically a linked list that uses these hash pointers of your blocks, and these hash pointers will be used instead of the normal pointers. So hash pointers are used to point to the previous block, this previous block. So this is this diagram shows the generic structure of your blockchain. So from here, you can see what are the generic elements of your blockchain involved in this blockchain technology. So the generic elements of your blockchain, if you see this, the network view of your blockchain, you will find there will be the users, or we call the nodes, and it will have the block, the participations, and it is a peer-to-peer network, and that will be available through the internet. But the generic elements of this blockchain, we say one is address, transactions, blocks, peer-to-peer network, scripting or programming languages, virtual machines to implement this blockchain, state machines, and the nodes and the smart contracts. These are few the generic elements of your blockchain. So what is the addresses of this blockchain means the addresses are unique identifiers that are used in a transaction on the blockchain to denote senders and recipients. So an address is usually a public key in this case to generate these black hashes. Or this public key is derived from a public key. So while addresses can be reused by the same user, the addresses themselves are unique. So in practice, a single user may not use the same address again and again and generate a new one for each transaction. So this newly generated address will be unique. So in Bitcoin application Bitcoin cryptocurrency is in fact a pseudonymous system. It is. So end users are usually not directly identifiable, but some research in anonymizing Bitcoin users have shown that user can be identified successfully. So as a good practice, it is suggested that users generate a new addresses for each transaction in order to avoid linking transactions to the common owner, thus avoiding the identification. So, and another element is transactions. So in these transactions is a fundamental unit of your blockchain. A transaction represents a transfer of value from one address to another address. We will discuss these transactions in details, how many bytes are used and what are the different elements are there in this transaction in the coming lecture slides. And the next one is block. So block means what? The block is composed of multiple transactions. It may have the multiple transactions like transaction 1, your transaction 2, transaction 3, and so on. Multiple transactions will be there in this block, and some other elements such as the previous block, a hash pointer, and timestamp, nuns will be there. We will discuss this block structure in detail in future coming lecture. So another one is the basic element of your peer-to-peer network. What do you mean by peer-to-peer network? As the name implies, this is a network topology whereby all peers can communicate with each other and send and receive messages. And for doing the mining process in the various applications of your blockchain, the scripting and programming languages are used. So this element performs various operations on transactions basically. So the transaction scripts are predefined set of commands for nodes to transfer tokens from one address to another and perform various other functions. Like a Turing complete programming language is there. We say Turing complete programming language. So this Turing complete programming language is a desirable feature of blockchains. So the security of such language is a key question and an area of important and ongoing research on this. Next one is to implement the blockchain, we require the virtual machines. So this is an extension of the transaction script, extension of your transaction scripts. So a virtual machine allows a Turing complete code to be run on a blockchain as your smart contracts, whereas a transaction script can be limited in its operation. So virtual machines are not available on all blockchains. However, various blockchains use virtual machines to run programs. For example, like your the Ethereum virtual machines and your chain virtual machines. And another important element of your blockchain technology is your state machine. So, a blockchain can be viewed as a state transition mechanism whereby a state is modified from its initial state to form to the next and eventually to a final form as a result of a transaction execution and validation process by the nodes of your peer to peer network in the blockchain technology. So then, what about the nodes then? A node in the blockchain network, or we say the peers or participants, the blockchain network that performs various functions depending on the role it takes. That is, a node can propose and validate the transactions perform mining to facilitate consensus and secure the blockchain is one. So this is done by following a consensus protocol. The most commonly used consensus protocol for this one is proof of work. We say proof of work. We will discuss about this. So nodes can also perform other functions such as a simple payment verification, validators, and many other functions depending on the type of the blockchain used and the role assigned to the node. So then comes to the smart contracts. These are the programs, these are the small programs that run on top of your blockchain and encapsulate the business logic to be executed when certain conditions are met. When certain conditions are met. So the smart contract feature is not available in all blockchains but is now becoming a very desirable feature due to the flexibility and power it provides to the blockchain applications. So what are the features of the blockchain then? We'll see the features of blockchain is, as we, if you recall the previous discussion, the blockchain that performs various functions. These are basic features. So blockchain performs various features as distributed consensus. That is, distributed consensus is the major underpinning of a blockchain. So this enables a blockchain to present a single version of truth that is agreed upon by all parties without the requirement of a central authority is one. So you have the transaction verification platform for smart contracts, transferring values between peers, generating cryptocurrency like Bitcoin or gold coin type, altcoin type, and then smart property, and where it also provides the securities. So we'll see this one by one in this The what is the transaction verification? Then in transaction verification, any transactions posted from nodes on the blockchain are verified based on a predetermined set of rules, and only valid transactions are selected for inclusion in block. So, whereas this platform for smart contracts means, as we discussed, a blockchain is a platform where programs can run the executable business logic on behalf of the users. So, as explained earlier, not all blockchains have a mechanism to execute smart contracts. This is now a very desirable feature. Another one is transferring value between peers. The blockchain enables the transfer of value between its users via tokens called tokens. So these tokens can be thought of as a carrier of values. Then generating the cryptocurrency, so this is an optional feature depending on the type of blockchain used. A blockchain can generate cryptocurrency as an incentive to its miners who validate the transactions and spend the resources in order to secure the blockchain. And another important function which is performed by your blockchain is smart property. For the first time, it is possible to link a digital or your physical asset to the blockchain in an irrevocable manner, such that it cannot be claimed by anyone else. You are in full control of your asset, and it cannot be double spent or double owned. It cannot be double spent, or your the double time you will be owned it. So that is the smart property. So just compare it with a digital music file, for example, which can be copied many times without any control. So on a blockchain, if you own it, no one else can claim it unless you decide to transfer it to someone. So this feature has far reaching implications, especially in digital right management. Digital right management and the electronic cash system, where double spend detection is a key requirement. The double spend problem was first solved in the bitcoins. And the next one is the provider of your security. So blockchain is based on proven cryptographic technology that ensures the integrity, as we say CIA, where you find the integrity and where A is your availability. Of availability of the data. So generally, confidentiality part is not provided due to the requirements of transparency. So this has become a main barrier for its adaptability by financial institutions and other industries that need privacy and confidentiality of transactions. So, as such, it is being researched very actively, and there is already some good progress made. So, it could be argued that in many situations, confidentiality is not really needed and transparency is preferred instead. So in Bitcoin, confidentiality is not really required. It is desirable in some scenarios. That's it. And you will have the, as we discussed, the immutability. Another functionality is the immutability. So this is another key feature of blockchain. Records once added on to the blockchain are immutable. There is the possibility of rolling back the changes, but this is considered almost impossible to do as it will require an unaffordable amount of computing resources. So, in much desirable case of Bitcoin, if a malicious user wants to alter the previous blocks, then it would require computing the proof of work again for all these blocks that have already been added to the blockchain. So this difficulty makes the records on a blockchain practically immutable. And another functionality we say that the uniqueness. Uniqueness. So this feature of blockchain ensures that every transaction is unique and has not been spent already. So this is especially relevant in cryptocurrencies where much desirable detections and avoidance of double spending are a key requirement in this. And the another one is your smart contracts. Smart contracts is another the functionality feature. So blockchain provides a platform to run smart contracts. So these are automated autonomous programs that reside on the blockchain and encapsulate business logic and code in order to execute a required function when certain conditions are met, as discussed. So this is indeed a revolutionary feature of blockchain as it allows flexibility, programmability, and much desirable control of actions that users of blockchain need to perform according to their specific business requirements. So let us see the applications of blockchain technology. So if you see some based on these features, the applications of blockchain technology, some of the applications of your blockchain technology uh, has the multitude of applications in various sectors, including but not limited to your finance, and you can say the government, or you can say the media. Other applications like law, and there are so many, and some arts. So more light will be said on these aspects here, but we talk about the hyperledger. The much more application is your for these kind of applications we use the hyper ledger, where the practical use cases will be we will discuss in detail for various industries in coming lectures, but it is sufficient to say for now that almost all industries have already realized that potential and promise of blockchain and have already embarked or soon will embark on the journey of benefits from this blockchain technology. So we'll try to discuss the structure of a block then. So in the structure of your block, uh, okay. So a node that starts a transaction, if you take any node, okay, this blockchain, as we said, the block is a container, the block structure that contains a series of your transactions. So in Bitcoin, a block may they contain more than 500 transactions on average. So the average size of your block is around 1 MB, an upper bound property which is proposed by Satoshi Nakamoto in 2010. So this may grow up to your 5 MB or sometimes higher. There are several conflicting views on this, but as of now, from my knowledge, I can say that it is up to 80 MB. So the larger blocks can help in processing a large number of transactions in one go, but the larger time for verification and propagation is required in this case. So if you see the structure of a block of your Bitcoin, it consists of two components. One is block header and list of transactions. So block header will be identified with the block hash, that is using the public key of the node, and the transactions. It will have certain transactions. So in that transaction, we are going to talk about this in details. So this is the outlook of your Bitcoin, having the block header and the transaction. So how these blocks are generated and how these blocks are accumulated in the blocks. So a node starts the transaction, any node that starts the transaction by signing it. If you have any transactions are there, that transaction will be signed with the private key of the individual or of that node. So the transaction is then propagated by using the flooding propagation algorithm in the network, by using desirable gossip protocols to peers, which validate the transaction based on the preset the criteria. And once this is flooded in the network, the transaction is validated and it is included in the block. It will be included in the block. So that block will be having the hash of some X, and this transaction will be included in the block. So at this point, the transaction is considered, suppose, confirmed. Then the newly created block now will become part of the ledger, and the next block links itself cryptographically back to this block. So this link is a hash pointer at this point. As said, if new block is created, that is this transaction is used to create this new hash value, hash of, suppose, the next one, suppose. So the transactions are then reconfirmed every time a new block is created. So usually 6 confirmations. It takes 6 confirmation. Sorry. 6 confirmations in the Bitcoin network are required to consider the transaction final. So here this step 4 and step 5 can be considered non-compulsory, as the transaction itself is finalized in step 3. However, the block information and further transaction reconfirmation are then carried out in step 4 and step 5. So when you think about what are the different the types of this blockchain technologies are there. Means if you say the types of the blockchain technology, well, we can say that the various types of blockchain technologies are there. So it is envisaged that due to the rapid development and progress made in blockchain technology, many applications will evolve over time. So some have already been realized, while some can be envisioned for the future based on the current state of advancement in the blockchain technology. So first, the three levels of your blockchain technologies are mentioned, described by a author called the Melanie Swan in her book Blockchain or the Blueprint for a New Economy. So let us see. The first one is your blockchain. Your blockchain version 1.0. So this was introduced with the invention of Bitcoin and is basically used for cryptocurrencies. Basically used for cryptocurrencies. As a Bitcoin is one of the cryptocurrency. This was the first implementation of cryptocurrency. It makes sense to categorize generation 1 of the blockchain technology to only include cryptographic currencies. So all alternative coins and Bitcoin fall into this category. So this includes core applications such as your payments and the applications. Your applications. And the second is your blockchain technology version 2.0. So the second generation blockchains are used by the financial services. The financial services. And the contracts are introduced in this generation. The smart contracts, as we just discussed, the smart contracts introduced in this generation. So this includes various financial assets, for example, like derivatives, options, swaps, and bonds. So applications that are beyond currency, finance, and markets are included at this tier. And the third tier is your blockchain version 3.0. So this generation is are used to implement applications beyond financial services in the financial services industry and are used in a more general purpose industries such as your government, health, media, and arts, which we just discussed. Right? So these are the different versions of your the blockchain technology, or we say the types of blockchain technology. So in the let us see in this how the blocks are going to be generated and how they work together, that we see here in this. So the generation of your blocks. Okay, so as we said, the how our transactions and blocks are related to each other in this. Suppose for generating a block, First of all, what happens? The transactions are hashed first, and those transactions are stored in a block, like called your block 1, block 2, like block 3. So in every block, transactions are hashed first. Transactions are hashed. So these hashes of two transactions are taken and hashed further to generate another hash. So this process eventually, as the new transactions are added, then by using the new block will be generated with the new transactions, and this name, the block header will be given as your previous hash will be used, and nuns, and the Markle root is used to give the name of these blocks. So this process eventually provides a single hash from all the transactions stored within that block that will leads to your Markle root. So this hash is known as the transaction Markle root hash and is stored in a block's header field, not in transaction field. So a change in any transaction, suppose a change in any transaction in this blocked hash, suppose will result in change in this block, that will result to change in this block. So that change in the root transaction hashes. So this helps in making transactions immutable. Making transactions immutable. So that is how these blocks are related to each other, that we can see. So let us see that in this how these blocks are related to each other in this case. So as we said, the every transaction is digitally signed and encrypted the transactions to verify by the peers. So cryptographic security concept primitives are used to ensure that the participants can only view the information on the ledger that they are authorized to see. So there are the in this how these blocks are related to each other. If you observe this diagram, the blockchain in this blockchain, every block is related to another block. Every block is related to another block here by seeing this the relationship. So there is a parent-child relationship between two blocks. If you take any two blocks, there is a parent-child relationship. So there can be only one child to a parent, and a child can have a single parent. So this helps in forming a chain in chain in blockchain. So blocks are explained a later section in this coming lecture, but in this diagram, if you see, three blocks are there: block 1, block 2, and block 3. So block 1 is the parent of your block 2. Block 2 is the parent of your block 3. So the relationship is established by storing the parent's block's hash. Storing the parent's the block hash in a child's block header. The child's block header. So here the block 2 stores the the hash of your block 1 in its header, and block 3 stores the hash of your block 2 in its header. So the question arises that who is the parent of your first block? Who is the parent of first block? So this we call that as your this has a concept of your genesis block, we say, also known as your first block. Genesis block or the first block. So this block is created automatically when the chain is first initiated. So you can say that a chain is initiated. With the first block known as the genesis block, and the formation of this block is driven through the genesis concept, as you know, new block. So let's see how are the transactions and blocks are related then. How these transactions and these blocks are related then. Okay, as we discussed, every block is having many number of transactions. Those transactions signed by the private key of the individual users, and then that will be flooded into the network, and after that they will be included into the block to generate the new blocks. So with this, I would like to stop the session here, and we'll start the application of your blockchain in the next session.